How do you know there's a root in between two values? That is what we're looking at today. So we have ln x, or natural log x, is equal to y. And we've drawn that there. There's an asymptote on the y-axis as well. Our second equation, y equals 3x minus x squared, we find our x values. So it crosses the x-axis at 3 and 0, and of course it goes through y at 0 as well. So our quadratic, which is negative, wonderful drawing as usual for me there, and we can see there's one intersection. So one intersection means one real root. And so we've shown that there with our graph by sketching the suitable pair of graphs. Ln x, natural log, ln, people call it different things. Make them equal to each other, our two equations there, and now we're going to plug in the values of 2 and 2.8 and pop it in your calculator. And if you see a change of sign when you sub in the both values of that, you will see that there's opposite signs when we know there's a root, because it crosses the x-axis and changes sign. It's continuous, there's opposite signs, so the change in sign means that the root exists between 2 and 2.8 in this question. We're now using the iterative formula to find the root, and we're given some details. You'll always be given details like 2 decimal places. On your calculator, on the right hand side, you'll plug in 2.4 equals, and then plug in ans, which is on your calculator, for whatever value of x in that formula is given. And from there we can start doing it. So x, 0 is 2.4, and you'll just basically go down this line of plugging in the next value. So in a sense, you can just put in 2.4 into that formula and then keep pressing equals, 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 equals until you get to a point where your answer lines up to 2 decimal places. It could be 3 goes, it could be 20. I think I've seen 20 once. It was a very expansive question. And here we see it more or less getting down to it. So 2.62 and then 2.62. Now just be careful here, just check. Our 5 rounds up, our 8 rounds up, so x is approximately 2.63,